Okay, we're going to go through and have just some videos for you guys to fall back on in case y'all are absent or just need to review some things for your last unit in Trig. So we're starting off with the first section dealing with trig equations, which was 6.2. So we'll have two sections of it, 6.2 and 6.3. Now the way this is set up, basically I have an example from the book and then I have an extra example. I'm most likely going to just skip the extra examples. So they're different colors. See, this is from the book and you can see how it's a different color. I'm most likely going to skip those. So don't think I'm just trying to fly through. I just want to work the ones from the book and be done. Okay, to start off with, you have various forms that you're going to have trigonometric equations. Basically, they can come in any form of an equation that you've had equations in the past. So start simple, linear method. So you all know how to do linear equations. Your gut instinct will carry you through this. So if you're solving for sine of x, you're going to move your 1 over, and it will be negative. And then you can move that 2 over because he's out front of sine. If it was in there on the angle, you could not touch it until you did the inverse sign. But this 2, he's out front, you can get rid of him. So what we're looking for is where is sine of negative 1/2. Now, thankfully, on this problem, it's talking degrees, so we can still think and work in degrees. This is a little bit different than the way we ended the last unit. We're not talking about just the restricted quadrants of inverse functions. We are actually talking about all 4 quadrants here. So we need the 2 quadrants where sine is negative because we have a negative ratio here. Sine is negative in both 4th quadrant as well as 3rd. You know, we didn't do anything with 3rd quadrant when we were talking about inverse functions. So you would, draw both of these out. But the main question is, whether you label all of this or not, what you're after is, what is that angle measurement? What is that reference angle? Well, opposite the 1 is always 30 degrees. Well, that's great, but I need to know what is the angle measurement from 0. How much do we rotate over? So what is that 30-degree reference angle? What does it give me in the 3rd quadrant? So 180 plus 30 is 210. And then we got to go all the way over here, and you're doing 360 minus 30, and that is 330. We can leave them like that because, thank goodness, this thing is asking us just for degrees. Here in a little bit, we'll swap gears and go radians on it. But that's the basics, and that's the foundation of how this works. Now, please note that to start off with, the easy problems, they are going to use ratios that are familiar to you. The ratios will refer to your special right triangles. So you're going to be using your 30, 60, 90s. You will be using your 45, 90s. You will also be referred to your unit circles. So if you have zeros or if you have 1s and negative 1s for sine and cosine, be ready to go into your unit circle. When it gets a little bit tougher, we're going to have values that you're not used to. Like if it's 1/5, you're going to have to pull out your calculator and it's just going to be an obscure value. So let's keep going. Again, we're going to skip the blue ones that are just extra. Okay, here's another way of using your trig equations. What if you had to factor? Now let's rewrite this so we can actually work on it. And by the way, whenever you're doing trig equations, don't lose your angle. Don't just write sine and leave the x off. Make a habit of keeping up with, it's technically called your argument. Keep up with that. Whether it be x, theta, alpha, beta, whatever it is, you keep up with your angle. Now, what is tempting is a lot of people want to come in here and say, ooh, I see sine on both sides. Let me divide. If you do that, you will lose sum of your solutions. That is a big, big, big no-no. Don't come in here and divide by a trig function. No, 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 no. And I'll show you why here in just a second. What you want to do is you need to push all of your terms to one side and get it equal 0. This is the same stuff we did back in algebra. You get all your terms on one side, then you can factor. Well, you do have a sign here and a sign there. So factor it out. You have tangent of x minus 1 now equals 0. Well, now your rules come into play for how do you solve equations where you have it in factored form. Well, the first factor gets set equal to 0, and the second factor gets set equal to 0. And you're going to solve them separately. Okay? Don't try to bounce around. Complete the thought, okay? So start one, go all the way to the end and complete it. Otherwise, you'll give yourself a headache. Now, you got to find out where is sine equal to 0. Now, hopefully it's ringing a bell. That for sine to have a value of 0, that is not a triangle. That is your unit circle. And remember, sine is the value in the back. So where is the second value equal to 0? And that is at 0 degrees and 180 degrees. Now, I don't remember. Did it tell us to leave our answers in? Yes, it did. In degrees or radians. You always have to look. So whatever it asks for, that's the way you need to leave your answers. It's common, guys, whenever it says 0 to 2 pi instead of 0 to 360. When you see that, that means we got to leave our answers in radians. So just make sure that you look and you pay attention. Okay, but we completed this thought. We took this all the way out and we figured out which angles gave sine to have a value of 0. So that's done. We can come over here and we can solve. All right, move the 1 over. Now, where does tangent have a value of 1? Well, first of all, it is going to be a triangle. Hopefully y'all are thinking, ooh, 45 degrees. But that's positive. Tangent is positive in first quadrant and in the third quadrant. Remember, it's still based on all students take calculus. That's what you're going to be using from here on out. If it is 45 degrees, the nice thing about using first quadrant is your reference angle is one of your answers. If you have 45 down here, that's 180 plus 45 is 225. So in the end, you have 4 answers. Now, you remember at the beginning, I was saying don't come in here and divide by sign? Because think about it. If you had divided by sign, wouldn't you have come up with tangent of x equals 1? The only answers we got from tangent of x equals 1 are 45 and 225. You would have never gotten 0 and 180. So half of your answers would be missing. So you want to make sure that you refrain from dividing by a trig function. Okay. Again, we're going to skip the practice problems and we're going to go straight into the next one. Ooh, there it is. I told you to watch for it. So we know that we've got to end in radians. So always be on top of that. So quadratic methods. Whenever you look at this one, the first thing that needs to catch your eyes is it's already equal 0. So you can attempt to factor it. Let's see here. Tangent of x. Tangent of x. 2 numbers that multiply to 2 and subtract to 1. 2 and 1 will do it. Signs are different and the big one is plus. So it does factor, which is very nice. And then it's like the other problem. You just have to work both of them out. Set that one equal to 0. Set this one equal to 0. And just pick one, work it all the way. This should have a little bit of deja vu. We just did it. Tangent is 1, and quadrant is 1 and 3, and yes, that's 45. All over again. Just make sure you give me both values. I need both quadrants. But remember, I can't leave it that way. I need radians. So you can think in radians the whole time, or you can do the switcheroo at the end. It really doesn't matter, just as long as you end in radians. Remember, this is pi, right? So think of that as 4 pi over 4. Go another pi over 4. And that'd be 5 pi over 4. All right? Then scoot over here. This is going to get interesting. Tangent of x equals -2. Okay? Well, first of all, it's tangent, and it's negative. Well, tangent is negative in second quadrant and fourth quadrant. So we know we're going in those two quadrants. That's 2 over 1. I don't know of a special triangle where tangent is 2 over 1. So you're going to need to use your calculator here. Let me grab one right quick. All right. Now you have a choice. You can work the entire problem in degrees, get your answers, and convert at the end, similar to what we did over here. Or you can go ahead and put your calculator in radians, and then when you get your answer on your screen, that is your answer. So I'm just going to go ahead and put it in radians, so I'm done. But one tip that you need to know, this little negative, that is for placement. It tells you which quadrants you're putting it in. Never put the negative in the calculator. Ever. So what you're going to end up doing is you're going to type inverse tangent, and then I'm just going to put a regular old +2. Now remember, I'm in radians. So as I'm in radians, I get this. This is what's on my screen. That is my reference angle. So that's what's inside this box. Now that's not the angle I want. That's just what's in this box. I've got to go in and figure out what's what. So I probably don't need to write it like that. If I need my two angles here, for this one and that one, I need to do pi minus 1.107. So you just got to type it in. Pi minus 1.107. And that one, there we go, got that one. And then you've got to do 2 pi minus 1.107. And that gives you both of your answers. It's a little weird, feels a little awkward, but it's not that bad. So that's how you're going to handle it, putting it in your calculator. It's two weird twists. It's the fact that you're having to use your calculator because it's not something normal. And then you're also doing it in radians, which makes it feel even more awkward. So you'll get used to it the more you do it. Okay, let's wrap this one up, and then I'll catch you in the next video. Okay?